Hi, my name is Mircea and welcome to the presentation of the Summer of HPC project Parallel Boundary Point Method, hosted by the Faculty of Information Studies in Novo Mesto and the University of Ljubljana. The boundary point method is an algorithm that solves semi-definite optimization problems. What is semi-definite programming exactly? Semi-definite programming, or SDP in short, is a subfield of convex optimization that unifies several standard problems, such as quadratic programming and some problems in nonlinear optimization. We can find main applications in combinatorial mathematics and control theory. In semi-definite programming, one optimizes a linear function subject to the constraint that an affine combination of symmetric matrices is positive semi-definite. The boundary point method has been developed by my mentor Jan Pov and sets itself as an alternative to interior point methods. These usually die out on problems with many constraints, while the boundary point method can handle a huge number of linear equations. Let's have a look at how the algorithm works. The set of all symmetric matrices of a particular dimension is called a semi-definite cone. We can think of the linear constraints as a hyperplane intersecting the cone. This will produce a feasible region. That is a set of points that satisfy the problem's constraints. The solution of a convex problem with linear constraints always occurs on the boundary of the feasible region. While interior point methods achieve optimization going through the middle of the cone, the boundary point method does exactly the opposite. The algorithm optimizes an augmented Lagrangian by means of iterated projections onto the cone of semi-definite matrices. Optimality is reached once the boundary of the feasible region has been hit. The goal of the summer project was to deliver a C++ parallel version of an existing MATLAB code. The following slides are an overview of the tools employed. In the first place, in parallel programming, we have many CPU nodes working independently. Usually, regular communication between processes is necessary and MPI is used as a message passing system. Linear algebra libraries are heavily utilized. Armadillo is used throughout the whole code for matrix operations and for numerical linear algebra features. Armadillo is a C++ template library that has the advantage to be usable and fast. By usable, I mean that its objects have an intuitive interface and its API syntax is similar to MATLAB. The library shows a good performance thanks to the fact that it integrates with BLAS and LAPACK, two famous packages that provide matrix algebra routines. In order to obtain considerably higher performance, Armadillo can be linked against OpenBLAS, a multi-threaded replacement of BLAS. This allows to compete with Intel MKL, which MATLAB relies on for matrix algebra operations. Eigen is a linear algebra library that is used in the code only for solving large sparse linear systems. Its solver is remarkably faster than Armadillo's and allows bigger speedups. The code was specifically prepared for a special type of semi-definite programming problems, thus characterized by a block diagonal structure. Basically, the matrix of coefficients and the constraint matrices are block diagonal, that is, they can be split in smaller submatrices along the diagonal, as the picture on the screen shows. This allows a parallelization strategy based on the number of diagonal blocks. These type of problems are useful to investigate some intricacies of graph theory. For example, graph coloring problems. Given a graph, we can ask ourselves what is the smallest number of colors needed to color the vertices of the graph such that no two adjacent vertices share the same color. This number is called the chromatic number and its computation is an NP-hard problem. We can use semi-definite programming to obtain good bounds for the chromatic number in polynomial time. Last but not least, I want to thank PRACE and the Summer of HPC theme for allowing me to experience the cultural aspects of the program as well as the technical ones. Thank you for listening.